Hello, everyone, and welcome to another episode of Eyes on Earth. Our podcast focuses on our ever-changing planet and on the people at EROS and across the globe who use remote sensing to monitor the health of Earth. My name is Jane Lawson, and I'll be hosting today's episode, where we're talking about the Global Ecosystem Dynamics Investigation, or GEDI for short. The GEDI instrument was deployed to the International Space Station in 2018 to acquire lidar, or light detection and ranging, waveforms to observe the Earth's surface in 3D. The GEDI lidar measures the height and density of objects, so it provides information such as surface elevation and tree canopy height and cover. We'll take a look at the purpose of the GEDI mission, how the instrument works, and how GEDI data are being used. EROS helps store and distribute GEDI data through the NASA Land Processes Distributed Active Archive Center, or LPDAC for short. Our guests today are here to talk about their work involving GEDI. Ralph Dubaya is a professor of geographical sciences at the University of Maryland and the principal investigator for the GEDI mission. Laura Duncanson is assistant professor in the same department at the University of Maryland and a research scientist on the GEDI mission. Ralph and Laura, welcome to Eyes on Earth.
Thank you.
Yeah, thanks so much. Great to be here.
Ralph, do you want to start by telling us what exactly GEDI is and what it does?
Sure. So GEDI is a really super cool instrument to begin with. As you said, it's on the space station. It's an instrument comprised of 3 lasers and a pretty large telescope. And as you said, we measure information about the structure of the Earth's surface. And so the GEDI instrument fires laser beams. And by the time the laser beam gets to the surface, it's pretty big, 25 meters across. We're essentially trying to map most of the land surface with these laser beams. And what we get back from GEDI, we fire a laser beam, we get back information on that vertical structure. How tall is the tree? How are the leaves and branches located vertically? Is there more canopy stuff at the top or at the bottom? And we also get a very good estimate of the elevation of the surface below the trees. This is something that's very difficult to get. So GEDI is a lidar, as you said, or also called the laser altimeter. It's the first space-based lidar that's been optimized to measure vegetation structure. And the community has been waiting almost 30 years to get this 3D information. NASA satellites provide really good information on the 2D aspect of the surface, such as you get from Landsat or MODIS, but we've really wanted that third dimension, and that's what GEDI does.
Why is GEDI important? Laura, do you want to start by telling us that?
Yeah, sure. So as Ralph said, we've had now 50 years of the Landsat record, which is just incredible. So being able to see where Earth is changing. But we've never had that third dimension that GEDI provides, which is particularly important for mapping forest carbon content. So like literally how big are the trees, how much biomass or carbon do they store? And so where we see in the past deforestation or forest loss, we haven't known how much carbon has been emitted to the atmosphere that's associated with those activities. So GEDI, by filling in that 3D gap, it's like painting carbon numbers onto the landscape. So we're going to be able to understand the carbon dynamics in forests much better, how much carbon is lost from deforestation, degradation, forest fires, etc. And then excitingly, how much is going back into those systems as we see forests starting to grow taller following those types of disturbances. So I think this is particularly important right now with so much attention on Earth's forests as really kind of a big partner in the fight against climate change. But we really have to understand their carbon dynamics so that we can manage them in that fight.
Ralph, do you have anything to add?
I think Laura covered that really well. It's again, we're a very carbon-centric mission, but the applications of GEDI are far-ranging, and we could use these data for biodiversity, for habitat, for forest fire modeling, to get lake levels, to get temperate glacier elevations, to see how they're melting and the like. So it's really a pretty varied instrument, and it's really one that the user community is pretty excited about.
So I'm curious what led both of you to work with GEDI. Do you want to tell us a little about your background? Laura, do you want to start?
Sure. So I have been really excited about remote sensing since I was an undergrad. I did some sort of summer research project in a lidar forestry lab, actually, back in Ontario, Canada, and just got fascinated by the data. And then when I was deciding what I wanted to kind of focus on as a researcher, remote sensing is so exciting. You can see all of these Earth processes, but a lot of them are pretty depressing to study. So, like you can watch urbanization, urban expansion, you can watch deforestation, you can watch glaciers retreating, sea ice melting. And the cool thing about forests is that there's a lot of hope there. So like they can actually be part of the climate solution. So yeah, my interest in forests really came with that forest being a hopeful thing to study. And I ended up actually coming down to the University of Maryland to do a PhD with Ralph back in the day to continue some of my earlier research, but expand it to space.
How about you, Ralph? How did you get interested in this?
Well, it's a long story, but to make it short, I will say that as a kid, I was super interested in astronomy and I would make telescopes, and I was also pretty interested in natural science. So when I went to undergrad, I started majoring in physics and astronomy. And after a while, I said, you don't get to look through these telescopes. I'm not sure this is what I really want to do. And as I was thinking about what I should major in, I remembered that as a kid, I used to really love I grew up in San Francisco. I used to really love going into Golden Gate Park, going to the Natural History Museum, taking notes on trees and plants and things like that. And so I took a geography class. This was at Berkeley. And I thought, I love this. And then I discovered that geographers make maps, and they make these maps using satellites. And hey, guess what? These satellites are made by NASA. And so I was like, I wanted to be an astronomer, but I could work with NASA doing this. And so I did my PhD looking at how solar radiation varies across mountains. Some parts of the mountains are shadowed. Some parts of the mountains are in sun. Being able to model that. And then we had an interest of understanding how much sunlight was actually going through the trees and hitting the ground below the trees or hitting a snowpack below the trees. So this then led me to collaborate with colleagues at NASA Goddard Space Flight Center, in particular Brian Blair, who had an aircraft lidar instrument. And we started looking at those data, and this is now in the mid-90s. And based on that interaction, we decided in the early 90s to propose a LiDAR mission to NASA. This was called the Vegetation Canopy LiDAR mission. And we actually got selected. It was the very first NASA Earth System Science Pathfinder mission. But we were too far ahead of our time. And that mission never launched. We couldn't quite get the lasers to work. And lasers in space is a very difficult task. So that then led to about almost 15 years of development, working with aircraft data, trying to get a LiDAR in space. And finally, we were able to propose again in 2014 and get selected and launch in 2019. So it's been a long time that we've been interested in LiDAR from the mid-90s. And it's really gratifying to get to that point. But you can see it was this long arc and a kind of crazy path to get there.
Yeah, that must have felt so fulfilling when you finally were able to make something work that you tried so long.
Yeah, it definitely was. It was, and Laura was at the launch. And speaking for myself, it was the greatest day of my life other than our kids being born. That's what I like to tell people, and it's actually true.
Well, it was like a birth, I'm sure.
It really was.
Ralph, do you want to tell us about what types of GEDI data are available then and where people can get them, researchers or whomever?
Yeah. So there's GEDI data that's available at footprint level, which is 25 meters across. And these data comprise various parameters: canopy height, canopy cover, canopy foliage profiles. In other words, how the canopy cover changes as a function of height, bare earth elevation. And importantly, we also produce estimates of biomass. And then many of these other data sets are also gridded. And so these are most researchers will use some combination of these kinds of data, whether it's footprint or it's gridded. The data are all available freely at the DAACs. And you already mentioned the Land Processes DAAC, the LP DAAC, which has what we call has the footprint level data. And then the gridded data and the biomass data are at the Oak Ridge National Laboratory, the ORNL DAAC. And they have great tools. LP DAAC has great tools for being able to look at the data and being able to download it.
Ralph, in what ways have you seen GEDI data fill a need for researchers who wouldn't be able to do what they're doing otherwise if they didn't have this GEDI data?
Well, there's so many ways. It's hard to articulate. The reason being is that I want you to consider this, is that before GEDI, the only spaceborne archive of LiDAR data that we had was from the ISAT-1 mission. And GEDI has already produced 2 orders of magnitude more data than that mission. And so you have this incredibly thirsty user community that's been waiting for 20 years to get this data. And all of a sudden, it's like a fire hose goes off and all this data are coming out. And so the users of the data span a variety of disciplines, they span a variety of organizations, and they span a variety of countries. And Laura could speak to this as well, but we have entire countries that don't have very good national forest inventories that are using GEDI data to try to get better estimates of their forest resources and the amount of carbon. We have the U.S. Forest Service that's using these data as well to look at carbon accumulation in U.S. forests. The DEM data are used by the U.S. Geological Survey as another example. So there's a lot of different kinds of users that are able to do this. But what's important is that there's questions we can answer now that we were never able to answer before. And individual researchers can address some of these because they can get GEDI data for their area of interest and ask a question such as, well, I know I've had deforestation in this area over the last 10 years, and I wonder how much of the forest has grown back and how much biomass has been accumulated there. And that's exactly the kind of question GEDI was created to help answer.
Laura, do you want to add anything to that? And then also tell us what you find most valuable about GEDI data for your research.
Sure. No, I think Ralph kind of covered a lot of the really exciting stuff that's going on. I was just at a conference in Germany last week, which was one of the first times I had been able to interact in person with a lot of the people who are using GEDI data internationally since before the pandemic. And it's so exciting to see the range of different applications that people are coming up with these creative ways of looking at GEDI that we hadn't even thought about before. So it'll be really fun over the next couple of years to see things. Certainly, we're excited about some of the data fusion, looking at forest regrowth, biomass recovery, biomass loss, etc. There's going to be some really interesting stuff coming out that we probably aren't prepared for. So that's all very exciting. I think Ralph also touched on the more operational use for filling some gaps in national forest inventories. A lot of countries around the world that don't have these field data sets to make the sort of reports on how much carbon is stored and is changing in their forest land. The kind of default approach is to just say, okay, in my country, this is our definition of forest, and we have this kind of area of forest nationally. And then to estimate the biomass, you multiply it by some sort of lookup table average biomass, which it's a pretty rough cut. And of course, with GEDI, we're like collecting billions and billions of these actual real spatially explicit 3D measurements, right? So it's sort of like we're doing a super NFI, but all over the world. And so some of the countries that are starting to explore the use of those data sets, of the GEDI data set, I think will be really, it'll open the eyes of other countries as to using these type of data for policy applications. So that's super exciting. And I think you asked about my own research. I would say a lot of what I do is sort of more focused on figuring out algorithms to translate the GEDI laser measurements into estimates of above ground biomass or carbon. But I think the really exciting stuff is more on the applied side. So what kind of science questions can we ask now that we have these data sets? I mean, something that my group's been working on for the last couple of years is a global assessment of how effective protected areas are at keeping carbon inside the protected areas, at avoiding deforestation, degradation, enhancing growth, etc. And so we just have a paper in review now, but our sort of grand total is that we think because of the existence of protected areas, we have an extra about 20 petagrams of biomass, which is roughly equivalent to 1 full year of annual fossil fuel emissions. So it's like a lot of carbon that would have probably been lost. And we had no ability to really quantify that before GEDI data were available. So those are the types of questions that I'm really excited about.
Would either of you like to add anything else today?
I might expand a little bit on something, and that's starting to expand that structural time series. So there's been, I don't know, like probably anybody who's bought a t-shirt in the last couple of years has like somehow magically planted a tree somewhere in the world. There's so much attention on these big, massive tree planting and ecosystem restoration activities, which is awesome, right? We're really understanding the power of these natural climate solutions, as they're called. But we don't actually have that much data to kind of back it up. We don't know if these mass tree planting activities are indeed sucking carbon out of the atmosphere, and especially if they're being treated like carbon offsets and sort of allowing pollution to happen. we really want to make sure that carbon is actually coming out of the atmosphere and it's staying long term on the ground. And I think that's an area that really GEDI hasn't had the time series to start exploring too much, but is a huge opportunity for the future. So being able to actually quantify the carbon sequestration associated with things like mass tree planting, I think would be really exciting.
I would just say lastly that in terms of the role GEDI could play going forward, we know that the U.S. as well as many other countries that have signed on to the climate treaty frameworks, in particular the Paris Accords, have to report out on their carbon emissions. And this has happened in 2020. It's going to happen again in 2025. And there's also activity around those events about how well we're actually doing. And so we really can't underestimate the importance of GEDI towards not just the U.S., but for the global community towards monitoring our progress so that we can meet these emission goals. And I think that's one of the really the most important reasons why GEDI should keep going and why GEDI has been such an important instrument.
Thank you, Ralph and Laura, for joining us for this episode of Eyes on Earth, where we talked about how GEDI is contributing to Earth observation science. And thank you to the listeners. Check out our EROS Facebook and Twitter pages to watch for our newest episodes. And you can also subscribe to us on Apple Podcasts and Google Podcasts.
This podcast
is a product of the U.S. Geological Survey, Department of Interior.